Alright, so this video is going to get into river basics. I'm going to get into the parts of a river and what a watershed is. And when I do this, I'm going to make a model to show you the parts of a river and what a watershed is. I'm not going to put a bunch of pop-ups up to show the definitions for you or the vocab words. You have to listen, pause often, write down what you need to, and I'm going to check those notes the next day for a stamp. So make sure you do take good detailed notes. If you don't have good detailed notes, you're not going to get a stamp. I'm going to talk about stream load. There's three parts to that. I'll talk about competence versus carrying capacity, and then we'll get into gradient, and then that'll wrap up the video. Okay, so let's talk about how rivers form. Here I have a little model to show a mountain. The mountain has a divide, which is a high point that separates two lower pieces of land. So here's one area of land, here's another area of land, and these Rice Krispies represent something called a divide. And that divide is what separates those two lower pieces of land. Well, all rivers start up in the mountains or the hills. Where does it come from? Well, it could either come from glaciers melting, and when they melt, that water that runs off that glacier will then cascade down that mountain and form a river, or it can come from the weather, like rain. So I have this little thing here. I made a little rain bottle, and I'm going to see if we can make a river here. So let's go ahead and simulate some rain. And right away, we notice that we have two very distinct rivers. And notice how these two rivers are not going to slam into one another. It's not going to happen because the divide separates these two river systems. These two different river systems are called watersheds. Here's one watershed, here's another watershed. And all that is any water that falls on this side of this watershed will be a part of this river. And any water that falls in this watershed will be a part of this river. Notice that it's changing. We get a couple little river channels here. We have some sediment that's moving with the river. And as we go through, there's sediment that's being carried from the high in the mountains down into the lower lands. This is exactly how rivers work. Now, what are the parts of a river called? Well, here we have the beginning of a river. That's called the head, or the headwaters. And down here we have the end of the river, and that's called the mouth. And then if you'll notice, we have this big deposit right here of sediment that formed right here. That's called a delta. A delta is a pileup of sediment that forms at the end of a river. Now we also have the sides of a river. Here's the side of a river, here's the side of a river. Now let me see if I can find something better to point with. Here's a knife. From dinner we had frittatas tonight. But here's the side of a river right here, and here's the other side of the river. Those are called the banks. Here's the pathway for this river. Here's a pathway for this part of this river. That's called the channel. The pathway that any river follows is called the channel. This one's a little bit more splotchy, but we still have, I think I messed up. I think I called the sides of the river the bed. Excuse me. The sides of the river are called the banks. If I said bed earlier, disregard it. It's called the banks. The bottom of the river is called the bed. The path that the river follows is called the channel. And if you'll notice, we kind of had this big river here, and then we had a smaller river come out of it. That's called a distributary. It's a smaller river that leads out of a bigger river. We'll talk about a tributary in just a second, because I don't have any littler rivers running into the bigger river here. So, to review, we have our divide, which is the highland that separates two river systems. This river system, they are called watersheds, and they're separated by a divide. We have the parts of a river. We have the sides of the river called the banks, the bottom of the river, which is called the bed, the path the river follows, that's called the channel, top of the river, or where it begins, called the head or the headwaters, bottom of the river, called the mouth, and then right over here we have this beautiful little deposit of sediment. Right here you can see it's a little bit more filled up with sediment right here. It's all flour. A little bit more filled up with flour right here. That's called a delta. Alright, so a minute ago I mentioned the word distributary and tributary, and here's what I mean by that. Here we have a river, it's flowing down a mountain, and sometimes we get little rivers that flow out of big rivers, and that's called a distributary. D-I-S-T-R-I-B-U-T-A-R-Y. That's a distributary. That's a little river that flows out of a big river. But then other times we get other smaller rivers that flow into a bigger river, and that's called a tributary. T-R-I-B-U-T-A-R-Y. And the whole river channel is flowing down this way. So we have distributary, which is a small river going out of a big river, and we have tributary, which is a big river, which is a small river going into a bigger river. All right, so next we're going to talk about stream load. And all that means is the stuff that's carried by a river. Now, it's not all the same. Depending on the size of the stuff, that stream load can get carried in different places. And here's what I mean by that. Here's a glass of water here. And I'm going to take, into that glass of water, I'm going to add some jelly beans. Now, if you notice, those jelly beans are all hanging down here on the bottom of the glass. If you remember, the bottom of the river, we called that the bed. This would be the bed load. This would be stuff that's moved by a river that only moves along the bottom of the river. That's the bed load. And then next we also have something called the suspended load. Here I have this jar and it's filled with just water and pepper. And if we kind of swirl it around a little bit and move it around kind of like a snow globe, hopefully you can see, you'll see this pepper kind of swirling around within the water. That's called the suspended load. The suspended load is any stuff that's being carried within the water. It's not moving along the bottom. It's not really floating at the top. It's being carried from here to here within the water. So in between and over here. So not on the bottom, not on the top, kind of right here in the middle. That's the suspended load. And all these little pepper flakes that are swirling around with the water, that would be the suspended load. And then lastly, we have something called the dissolved load. And to show that, I have this jar here. And in the jar I have some salt. I'm going to add a little bit of water. And then I'm just going to mix this up just a little bit here. And now I've dissolved that salt into the water. That's called the dissolved load. Why? These are generally minerals that will break apart in the water or dissolve within the water and become a part of the actual water itself. So that's what the dissolved load is. You're not going to see it floating around. You're not going to see it scraping along the bottom. It's a part of the actual water itself. Almost became a part of the chemistry of the water. So, 3 types of stream loads. Again, stream load is just the stuff that's carried by a river. We have the bed load, which is the stuff that's carried on the bottom of the river. We have the suspended load, which is the stuff that's carried within the water of the river. And then we have the dissolved load, which is the stuff that becomes a part of the water itself, the dissolved minerals and stuff like that. I like the black M&Ms, the black licorice ones. They taste delicious. Okay, so to help us understand competence, my daughter Maya is going to help us out. Maya, can you lift that 5-pound weight?
Yeah, see?
Pretty easy. Excellent. Put it down. Now, try to lift this 20-pound weight.
Oh, look, I can't.
Try again.
I got it with 2 hands.
All right, put it down carefully. Thank you very much. You're very strong. Now, what Maya just demonstrated was competence. Competence is the ability of a river to carry, or the strength of a river to carry sediment. She was able to lift that 5-pound pretty easily because her competence is pretty good with the 5-pound weight. But when she goes to carry heavier things, such as the 20-pound weight, put that one down. Try to do the 20-pound weight. When she tries to carry the heavier things, it's really hard for her because her confidence on carrying the 20-pound weight isn't so good. Rivers do the same thing. When rivers can carry a lot of sediment, big sediment, their competence are pretty high. When they can't carry big sediment, then their competence is pretty low. Okay, so to help us out with this part, this is my daughter Belle. Today's her birthday. Belle, say hi.
Hi.
All right, now Belle's going to help us demonstrate what carrying capacity is. Carrying capacity is how much stuff a river can carry. So let's see. Belle, can you hold this orange? Holding one orange, not a problem. Now I'm going to give her an apple. So now she's holding an orange and an apple. Now I'm going to challenge her carrying capacity by giving her 2 more oranges to hold. And now we're almost there because she almost dropped one. Let's see if she can hold another orange.
No.
And how about an apple? Let's see if you can hold that apple. Hold them up so everybody can see. Wait, you can do it. You can do it. Hold your hands up. Hold your hands up slowly. Oh,
I can't.
See, she reached her carrying capacity. And what that means, she reached the maximum amount of stuff that she can carry. Rivers are the same thing. Rivers can carry a small amount of stuff. Rivers can carry a lot of stuff. How much stuff they can carry is called carrying capacity. A high carrying capacity, carry a lot of stuff. A low carrying capacity, they can't carry a lot of stuff. So that's what it is. All right, a couple more quick things to talk about. We're going to talk about gradient and discharge. Let's say we have River A here, and River A is pretty steep, flows down. And here's River B, and we'll assume that River A and B are the same length. And so let's just say they're each 1 mile long. 1 mile. 1 mile long from one side to the other side. From there to there is 1 mile. Notice that River A is much steeper than River B. It's said to have a higher gradient. And what that means is it has a greater change in elevation over this 1 mile distance, or over that measured distance. So it has a bigger change in its vertical drop than River B does, given that same distance. And if we were to kind of put a little triangle on this, you'll notice that River A has a much higher slope than River B. River B has a very gentle slope. River A has a very high slope. So it has a higher gradient. The next thing to talk about would be river discharge. And the only thing that river discharge means is the volume of water that flows through the river at any one time. So we could take a look at two rivers here. Again, here's River A, and we'll say this is the width of channel for River A. And here's River B. Now let's assume they have the same gradient. River B is going to have a higher discharge simply because the river channel is wider. Now there's a couple of other things that can control discharge, like the gradient, but we're going to go ahead and take a look at that in our lab instead of getting into it now. Okay, so in this video we got into a whole bunch of stuff. We did a whole bunch of the basics on the parts of a river and watersheds. Put a list of words here. I think I covered all these words. There may have been a couple more that I hit that are not on this list, but if I said it and I stressed it, it's something you should definitely know. The stream load, suspended, bed, dissolved. Competence versus carrying capacity, gradient. I also had a discharge on there. That was not on the original objective list, but we have it now. Again, if you have any questions, feel free to send me a message on Edmodo or an email. I'll see you in class tomorrow. We will have a quiz on this material.